In this lab, we will determine the solubility product constant of the sparingly soluble salt silver acetate. First, you will measure 30 milliliters of 0.300 molar sodium acetate and 30 milliliters of 0.300 molar silver nitrate. Next, these solutions are poured into a 125 or 250 ml flask, and the resulting solution is shaken vigorously. While sodium acetate and silver nitrate are both soluble solids, once the solutions are mixed, the silver ion comes into contact with the acetate ion. Silver acetate is a sparingly soluble salt and soon begins to precipitate out of solution. The solution is shaken every 5 minutes for a period of 20 minutes to ensure precipitation of the silver acetate is complete. Next, the solution is gravity filtered. Your filtration apparatus consists of an ordinary Erlenmeyer flask, a glass or plastic funnel, and a piece of filter paper. The filter paper is quartered and inserted into the funnel. The purpose of a filtration is to separate a solid from a solution. In this case, the solid is silver acetate, and the solution is saturated silver acetate. Once complete, the solid and the filter paper are discarded. The solution is kept for the titration. "20 milliliters of the saturated solution are then measured for the titration. Before starting the titration, we record the initial volume of the burette. The volume here is past 0.30 milliliters, but not quite to 0.40 milliliters. We estimate the hundredths place, and we will call it 0.39 milliliters. The solution is transferred to a 250 milliliter flask, and approximately 2 mL of ferric ammonium sulfate are added. The exact volume is not critical, so a disposable pipette may be used. This functions as an indicator. Finally, we are ready to begin the titration. Remember that our goal is the determination of the solubility product constant for silver acetate. To do this, it is necessary to determine the concentration of the ions in solution. The concentration of silver ion is determined by titration with potassium thiocyanate. Silver thiocyanate is much less soluble than silver acetate, so that as the titrant is added, you should begin to see the formation of a white precipitate. This is silver thiocyanate. Here we approach the end of the titration. Note the rate at which the titrant is added is slowed. Also note the local color change around each drop. Furthermore, with each drop, the color takes longer to disappear. Eventually, the silver ion in solution is exhausted. Once there is no longer any silver to precipitate out, the thiocyanate begins to combine with the iron 3 to form the iron thiocyanate complex ion. Ordinarily, this appears blood red in color. Here, greatly diluted down and mixed with the silver thiocyanate precipitate, it appears closer to pale orange in color. Stop the titration with the first color that persists throughout the entire solution. Finally, we record the final volume of the burette. Remember to read the bottom of the meniscus. Here the volume is past 41.7, but not to 41.8. We will call it 41.79.